Hello learners. In this video, we are going to learn about battery management system and its architecture. A battery management system is an intelligent electronic control system that monitors, protects and manages the operation of a rechargeable battery pack. It is considered the brain of the battery pack because it continuously measures battery parameters, estimates the battery condition and controls the charging and discharging cycles, also balances individual cells and communicates with other electronic systems. BMS plays a vital role in electric vehicles, hybrid electric vehicles, battery energy storage systems, solar power systems, robotics, aerospace, etc. Without BMS, lithium ion batteries may suffer from overcharging, deep discharge, overheating, or short circuits, which can reduce battery life or create serious safety hazards. So, a typical BMS architecture consists of the following major blocks. First one is the battery pack, then the cell monitoring unit, then the BMS master controller and communication interfaces. So for all we need the power supply to work with, and output and actuator control, protection and monitoring functions through these measured parameters of the BMS. Okay, so let us see about the battery packs first. So the battery pack consists of multiple lithium ion cells in series or parallel or combination of both to achieve the required voltage and capacity. Series connections increases the battery voltage to the required value of the entire battery pack. So this is the effective voltage of the battery pack through which the series and parallel combinations we have achieved. Okay, so the battery pack provides sensing points for individual cell voltage. So this is the sensing point, so it provides individual cell voltage, and for pack voltage, charge and discharging current, cell temperature and insulation resistance. All these informations are sensed through these sensing points, and these forms the basis for all BMS control decisions. Okay, so all the decisions will be made by the controller through these sensing informations only. The second one is cell monitoring unit. So the cell monitoring unit is responsible for monitoring every battery cell in the pack. So each MCU, each CMU, cell monitoring unit, contains a dedicated cell monitoring integrated circuit, that is IC, cell monitoring IC, that measures electrical and thermal parameters of the cells. Main functions: cell voltage measurement, temperature measurement, cell balancing. In cell balancing, we have two types of balancing: passive cell balancing and active cell balancing. Then fault detection. So the fault detection means over voltage, under voltage and open wire conditions, sensor failures, communications errors, etc. So these are all happens under the cell monitoring unit. Then third one is BMS master controller. So the master controller is the central processing unit of the BMS. It usually consists of a high performance microcontroller or automotive grade processor. So its major responsibilities includes data acquisition through the MCU, so which collects cell voltages, pack voltage, current, temperature and fault informations from all CMUs, that is cell monitoring units, and state estimations such as state of charge, which indicates the remaining battery capacity, and state of health, which represents the battery aging and remaining useful life, and state of power, which determines the maximum power that the battery can safely deliver or accept under the current operating conditions. And thermal management. So the BMS controls battery temperature by operating cooling fans, liquid cooling pumps, heating elements. So these cooling methods we have seen in the previous videos. Okay, you can search it out. Then charge and discharge control and protection algorithms for over voltage, under voltage, etc., short circuit, over temperature, etc. Then diagnostics and data logging. The BMS stores fault history, charging cycles and discharging cycles, then operating temperatures, battery usage statistics, etc. So these records help technicians to diagnose battery problems and evaluate battery health. So communication interfaces includes the CAN, that is controller area network for communication between VCUs, vehicle control unit, motor controller, charger, battery charger, and dashboard, etc. So for this, serial interfaces are used like UART, Bluetooth, BLE, etc. Then power supply module provides the required uh, power supply to operate the BMS, which includes DC-DC converter, isolated power supply, and 5 volt and 3.3 volt voltage regulator. So output and actuator control is controlled by BMS, which is connected to several external devices to ensure safe battery operation, which actuates the main contactors, pre-charge contactor, discharge contactor, cooling fan, and pump control, etc. So these are all about battery management system, and we will look about how it is working. So the architecture includes battery packs, cell monitoring units, cell balancing circuits, master BMS controller, memory modules for battery storage, that is for data acquisition and serial communications, power supply module, and actual control and protection circuit. This is the summary of the architecture that what we have seen in the previous slide. Okay, we will see about the uh, next topic in upcoming classes. Thank you.